serious.
Alright, so we are starting on the second page. So we are going to talk about why we use these angles or these exact values. Because in a previous class, if you learned your unit circle, maybe you were told to memorize these, maybe you were told why, maybe not. But we're going to go over why. So we're going to do some things to these triangles, so just bear with me for a second. What type of triangle is this? It is a right triangle, but more specifically, what type of?
45.
That's talking about the angles, but if I had to label this type of triangle, it's an isosceles triangle. What do we know about isosceles triangles? It has a right angle, yes. Two of the angles are equal, and so we said that already. It has a 90-degree angle. Two of the angles are the same, and two of the sides are the same. So I could say that this could really be A, or this could really be B. It's the same thing, since they're the same side. How do we solve for the lengths of a triangle? Pythagorean Theorem. So if we were using Pythagorean Theorem with the variables we have now, that would be a squared plus a squared is c squared. So we could combine these two. And let's solve for c. So how would we do that? Yes. So when we take the square root of both sides, this really becomes a times the square root of 2, because the square root and the square are going to cancel. Now let's specify some more details for this triangle. Let's say this is a triangle on our unit circle. So now C, our radius, is equal to 1. So I can say that this equation is equal to 1. So I can now solve for A. On our unit circle, the radius is always half. So now if we're solving for A is going to be 1 over the square root of 2. Can we leave that like that? No, we need to rationalize. So we can say A is the square root of 2 over 2. So if I needed to find the sine of 45, what would that be? It'd be the square root of 2 over 2 over 1, which is just the square root of 2 over 2. What about the cosine of 45? It'd be the same thing, the square root of 2 over 2. What about the tangent of 45? 1. Because you have the square root of 2 over 2 over the square root of 2 over 2, which is the same thing, so it would just be 1. We're going to do the same thing to the other triangle, but that one has a little bit more steps. I'm constantly losing. Seth. Alright, so this entire triangle was an equilateral triangle. What do we know about those? What'd you say? All the sides are the same length, and all the angles are the same. So before this happened, all of these angles were 60 degrees. All of the sides were the same. So when I split this down the middle, this became 30. And a couple other things happened. Could I say that A is equal to 2 times, I'm sorry, C is equal to 2 times A? Yeah. Yes, because we just split it down the middle. So we're going to use that, but later, because I forgot the order in which I'm doing this. So let's use that and go back and solve for our sides. So using our Pythagorean Theorem, I'm going to say that this is now 2a. I'm not using c. So a squared plus b squared equals 2a squared. So now again, I can combine my a's. And let's say I wanted to solve for b. I would do that by doing what? Taking the square root again. Just like in the first triangle, just the 3 is going to end up underneath the square root. So I can say b is sum a times the square root of 3. Now we'll come back to that. We know from our unit circle that the radius is 1, so if I now say that this value is 1, I can solve for a. So a would be 1/2. Using that a value, I can now solve for b. So now I have c equals 1, b equals the square root of 3 over 2, and a equals 1/2. As you may know, is your 30, 60, 90. Now, let's find the sine of 30 degrees. What would that be? 1/2. The cosine of 30 degrees, the square root of 3 over 2. Now the tangent of 30 degrees, we have to do a little bit of work. Because that's going to be your opposite over adjacent. So that's 1/2 over the square root of 3 over 2. Fraction within a fraction, what do we do? Multiply by the reciprocal of the denominator. So we end up with 1 over the square root of 3, but we need to rationalize. And we can find the same same ratios, but for 60 now. What would the sine of 60 degrees be? Root 3 over 2. The cosine of 60, 1/2. And again, to find the tangent of 60, we end up with this fraction, but flipped. The square root of 3 over 2 over 1/2. So multiply by the reciprocal of your denominator. So below there's a table of 60 is the square root of 3. So all of the numbers we just figured out, fill out that table. So we did 30, 45, 60 for sine, cosine, and tangent. Just fill out those. So as we're going around our unit circle, we're going to use really those values a lot, but I want to fill out this chart first. Some of you may know these already, and that's fine. I do want to jump back up here for 1 second. We talked about this previously, but just so you see it in context, anytime you land on 0, 360, 90, 180, 270, or any of those coterminals, those are quadrantal angles. Because our unit circle has a radius of 1, I can say that this would be the point 1, 0. This would be the point 0, 1. This would be the point negative 1, 0. And this would be the point 0, negative 1. So what that really means is, remember that each of these ordered pairs, x, y, can really be changed to cosine theta, sine theta. So that means the cosine of 0 or the cosine of 360 is 1. The sine of 0, the sine of 360 is 0. Cosine of 90 is 0. Sine of 90 is 1. And you follow that pattern all the way around. Alright, so for, we know this is 0 to pi. What is 30 degrees in radians? Pi over 6. What is 45 degrees in radians? Pi over 4. What about 60 degrees? Pi over 3. 90 degrees? Pi over 2. 180 we know is pi. 270? 3 pi over 2. So here, if we're given this xy, really we have our sine and our cosine. Cosine would be 1, sine would be 0. Tangent, the x, y, y definition for tangent is what? Y over x. Or sine over cosine. So tangent would be 0. Or 0 and 360. Since we have sine and cosine here, the ordered pair would be root 3 over 2, 1/2. Here, your ordered pair would be root 2 over 2, root 2 over 2. For 60, this would be 1/2 root 3 over 2. And then we just need to fill out the others. So if this is 0, 1, that means cosine is 0, sine is 1, tangent is sine over cosine. So what would the tangent of 90 be? Undefined. Same thing, cosine would be -1, sine is 0, so tangent is 0 here. And then in 270, cosine is 0, sine is -1, so tangent is undefined again here. So this is the table method. You could use this entire table. You could really just use these 3. Doesn't really matter. But we're going to talk about some patterns to help you remember them. But really, those are just for the first quadrant, the positive first quadrant. You use those same ones all the way around, but in different ways. What'd you say? Yeah. So Miss Bordelon said this mnemonic to me. I usually use all students take calculus, but whichever one you prefer. A smart trade class, all students take calculus. Someone said all students taste chocolate. Whatever you want. But those mean, A, everything is positive. All is positive. All of your trig functions will be positive in that first quadrant. S, your sine will be positive, and because sine has a reciprocal, your cosecant will also be positive there. But that means everything else will be negative. Cosine, secant, tangent, cotangent. T is for tangent, so tangent will be positive here, cotangent will be positive here, sine and its reciprocal, cosine and its reciprocal will be negative. And then C for cosine, so cosine and secant will be positive in the fourth, everything else will be negative. Another way you can think about this is just as the xy plane. We know that for our x's and y's, these are positive x's. C is x, so that makes sense. These are negative x's. C is x, so C is negative here. These are positive y's. S is y. It's positive. And these are your negative y's, and y is negative on there. So however you remember that, remember that. These ordered pairs are just your cosine sine, saying which one's positive, which one's negative. So this is how we're going to use what we just found all the way around our unit circle by using reference angles. We're going to use whatever was in the first quadrant as our reference angle. We're going to go back to those angles, back to those exact values. Anything in the second quadrant, we're going to take 180, subtract the angle, and look for that angle back in the reference, back in the first quadrant. Anything in the third, we're going to take that angle, subtract 180, find whatever that is, reference back to the first. Anything in the fourth, though, we need to do 360 minus that angle. So, for example, let's do 30. Let's say 30 is my reference angle. What's the ordered pair for 30? Three over 2, 1/2. Pick one of the angles or radians in your unit circle in the second quadrant.
You said radians or angles?
Yes, either one. So 3 pi over 4. So 3 pi over 4 is 135. 135 minus 30 is 105. Oh, I said the wrong thing. Sorry. 180 minus 135 is 45. So I probably shouldn't have started with that one. I probably should have just wrote all of them up here. Sorry, that was my mistake. Okay, so you pick 135. 180 minus 135 is 45. We know 45 is this order pair, but since it's in the second quadrant, what's going to be positive? Sine. So that means 145 in the second quadrant would be positive sine but negative cosine. 135, I said 145. So as long as we know what 30, 45, and 60 are, we can always find all of these angles. Let's do this again though. Pick an angle in the third quadrant, degrees or radians. 7 pi over 6 is 210. So 210 minus 180 is 30 degrees. 30 degrees is this. What's positive in the third quadrant? Tangent. So that means both of these would be negative at 210. So really you're using these and you're using your signs to figure out, are they positive, are they negative? But we're always using these numbers. Pick an angle in the fourth quadrant. 11 pi over 6, so that's 330. 360 minus 330 is 30 degrees. We know this is 30 degrees. What's positive in the fourth? Cosine. So that means only cosine would be positive there. So it would be positive 3 over 2, negative 1/2.
You just say, stop doing it like how you're doing. Not like those numbers, like I know what it's from, how you're figuring. Like, I like how you close your mouth after you
The signs, like whether it's positive or negative.
I don't know. Just, can you do that?
Sure. Pick some angle that's not in the first quadrant.
Pi.
Let's stay away from that because that's its own. 5 pi over 4, so that's 225. 225 minus 180 is 45. So that's in the third. What's positive in the third? Tangent. So that means both of these values are going to be negative. So this would be negative root 2 over 2, negative root 2 over 2.
The answer is based off the angle you get. But it's for the original angle.
So I have a question.
Yes.
What do you subtract from 180 or 180?
It depends on which quadrant you're in. So if you're in the second, this is such. Sorry. If you're in the second quadrant, it's 180 minus your angle. If you're in the third, it's your angle minus 180. If you're in the fourth, it's 360 minus your angle. So it depends.
Wait, why are they both negative if I thought tangent was always positive?
Tangent is positive, yes. But that's sine and cosine. Now, before we get to these examples, I want to do this. So we need to fill this out in radians and degrees again, but now we're going to fill out our order pairs as well.
Can't do that.
We will be able to.
Oh wait, we're not allowed to say can't.
Are we not? Yes.
I am not capable of labeling that whole entire unit circle yet.
Not yet.
With the
But-
order pair.
Not yet.
Yes. Yes.
Yeah.
Yes. I can't. I mean, I'm
Not
not capable of it yet.
I can't do.
We're not allowed to say can't. So the first
What's
one is
the
not allowed.
first radian?
Unacceptable rules.
Oh, pi
Can't.
over
Next.
pi over 4.
Next.
Or pi over
3.
3.
Keep going.
Pi over 2. I'm scared.
2 pi over 3. 3 pi over 4.
5 pi over 3.
Stop going so fast.
7 pi over
7 pi over 6.
5 pi over
5 pi over 4.
We all know this.
4 pi over
4 pi
3.
over 3. Hold on, guys. I can only write so fast.
4
4 pi over 3.
3 pi over 2. 5 pi over 3. No.
5 pi over 3. 7 pi over 4. 11 pi over 6. Wow.
2 pi.
You don't say.
I don't know if you need the ones below or the ones up, so just let me know. I'll scroll up and down.
So fast.
But you know the whole thing. Yes, you do.
Alright, in degrees. Okay, here we go. 30.
45.
Right up.
Calm down, man.
Then 60.
90.
90. 120. 120. 135. 135. 150. 150. 180. 180. 225. Wait. 225. 240. 270. 300. What? 315. And 350.
That's bad. Technically, you had it for 2 years.
Somewhere in this, put the letters A, S, T, C. Sucked. Except if you think about it like that, remember that you went counterclockwise, so all of your angles are now negative.
Oh, sorry.
Astica.
No, it's
It starts
Yes.
with A and it goes to S and then to T. Astica.
Whatever else you
Why'd
remember.
you say it so aggressively?
Alright, I'm also going to put the reference angles in here. So this is whatever it is, that's our reference angle. This is 180 minus our reference angle. This is our angle minus 180. And this is 360 minus our angle.
oh, so like
So the
only in the fourth
all of
one.
A is theta.
Yes.
Or, right? Yeah. Just making sure.
Yeah.
Yeah. And then all of F.
So,
is the cosine of 30 degrees or pi over 6? Root 3 over 2. What is the sine of pi over 6 or 30 degrees? Half. Cosine and sine of 45. Root 2 over 2. Cosine of 60 degrees or pi over 3. Half. Sine of pi over 3 over 60. Root 3 over 2. I also skipped one. This should have been 1, 0. This is 0, 1.
Is this what's all going on our quiz?
Yes.
Can we see the quiz right now?
Oh, no. What did you say?
What is it?
I need to be alone.
Like, we kind of fill out
Because when we go home and come back
Like
next
everything.
week,
Everything.
Is it
you
even
fill in
written
the
down?
blanks, you're not going to study.
Like, are you
It will
gonna
have
say
a degree symbol. It'll have a fraction bar for your
So you might
series
as well just
Okay.
fill now. It's so
and
early.
for these, and it'll have parentheses for your order pair.
And do we ever have to give the order pairs for this one or the one?
She's having a test.
Okay,
But I don't know something else. The last teacher, like, taught us a way to remember the.
We're going to talk about patterns in a second. Okay, so 180 minus 120 is, what's 180 minus 120? 60. So if I'm looking at 60 and only sine is positive, that means this is going to be negative 1/2 root 3 over 2. $180 minus 135, well, we did that one. It's 45. Only sine is positive, so this will be negative root 2 over 2, root 2 over 2. 180 minus 150, 30. So if I'm looking at 30, it's going to be negative root 3 over 2, 1/2. This is going to be negative 1, 0.
Wait, I missed the last one.
Which one?
Like, just up a little.
$210 minus 180, 30. So if we're looking at 30, it's going to be this ordered pair, but tangent is positive, so both of these are now negative. $225 minus 180, we did that one as well. It's 45, so if we're looking at our 45s, it's going to be this ordered pair, but both are negative. $240 minus 180, 60. So if we're looking at our 60, it's going to be this order pair, but both are negative. This is 0, negative 1. $360 minus 300, 60. So if we're looking at our 60, it's going to be this order pair, but only cosine is positive, so sine is negative. $360 minus 315, 45. So for the 45 is root 2 over 2, but sine is negative. $360 minus $330. 30. So that would be this ordered pair, but sine again is negative. Alright. We're going to do a couple different things, and we're going to continue patterns tomorrow. Everyone hold out your right hand in front of you, though. No. So this is one of the ways you could remember this. So for your hand, pretend that you have a root 2, a fraction bar with a square root over 2.
Can you draw that out?
Sure. This is going to be terrible.
Yes.
Yes.
So why didn't you go all the way in? You just got
Okay, pretend you have a square root over 2 on your hand.
That's not what
your
I was
hand
imagining. That's what.
That ain't no hand.
Go in the box.
I'm not an artist. So, anytime we go below, anytime we're going below, those are going to be your sine values. Anytime you go above, those are going to be your cosine values.
Oh, sure.
Alright, so let's start with our thumb. How many is above our thumb? How many fingers? 4.
None.
None.
Oh.
Who said four?
How many fingers are above your thumb?
No.
Did you skip that?
Okay, so that number goes inside.
What?
Yeah, that number goes inside your square
Yeah, I'm not going
root. 0, 0. So that's 0. So that would be how much your sine is. Sorry, I skipped one also. I skipped something, sorry.
Yeah. It's like 1 and 2. So it's 3. What do you want? What does Ricky do? Wait, what's the one that did this?
I started at the wrong finger. That's the problem. Okay, we start at 0. Okay, let's start over. Your pinky is 0.
Wait,
what?
Your pinky is 0, so hold it like this. How many fingers are above?
4.
4. Put 4 in your square root. You get 2, and then the whole thing is 1. So that means at 0, your sine value is 1.
Wait, do that again.
No, this is just one way to remember.
Put 4 underneath that square root. Equals what? Yes.
How many fingers are below? Oh, I said above. That was cosine. How many fingers are below?
The pinky?
Absolutely.
0. 0. So if we put 0 in, we get 0. So the sine of 0 is 0. I said sine first, but I meant cosine. Cosine of 0 is 1.
What is this?
So if we're looking at our ring finger, how many fingers is above? 3. So if we put 3 in here, we get the square root of 3 over 2. So above, the cosine of pi over 6 is the square root of 3 over 2. Below, how many fingers is below your ring finger? 1. So if we put 1 in here, we get 1/2. So that means the sine of pi over 6 is 1/2. For your middle finger, how many fingers is above? 2. So if we put 2 in here, we get square root of 2 over 2. So above, cosine of pi over 4 is root 2 over 2. Below, it's also 2. So it's still root 2 over 2. For your index finger, if you go above and you put 1, this would be 1/2. So the cosine of pi over 3 is 1/2. Below it takes 3. So if you put 3 in, the sine of pi over 3 is root 3 over 2. And now if we do the sum again, above is 0. So if we put 0 in here, we get 0. So the cosine of pi over 2 is 0. Below is 4. So if you put 4 in, you get 2, which is 1. So the sine of pi over 2 is 1. So that's one way to remember it. There are also so many patterns around us, or around your unit circles. One of them is if you look at your reference angles, this goes 3, 2, 1, 3, 2, 1. If you're just looking at your numerators, everything's always over 2. What are some other patterns we see? Here. It could be anything from the radians, degrees, the exact values. What other patterns do you see?
Is it the same?
The same.
Like the front sequence? It's like 1/2 square root of 3 over 2.
So yes, they should be the same. So I'm going to highlight which ones are the same. So we know this was the same as this, which was also the same as this, which was also the same as this. So if we're looking back to how we got those values, we got those values from a triangle. So if we flip that triangle, it would make sense that our x is now negative, but our y is positive. If we flip that triangle again, it would make sense that x and y are both negative. If we flip that triangle just here, it would make sense that our x is positive, but our y is negative. It'd be a lot. Same thing here.
Wait, is this my smile?
No.
Big shocks.
Candy? Can we stop? We need to do it all fresh.
Brown, you guys get
So I'm going to do this last one and then I'll let you try it. When we were finding this triangle, those ended up being the same all over the place. So we will talk more about patterns tomorrow, but we're going to pick up with this. I know it's next week. I don't know.
But it's not as funny.